Now, I think there was a request also for the third question. Is that correct?
That's correct.
Under the same exam?
Yeah.
Okay, that really doesn't pertain to this particular section of engineering surveying. It's more back to the first session that we had. But I guess I can speak to it. Yeah. Question 3, which I now have on the screen. In Blackhout and the other people, this urban surveying and mapping extract or excerpt, there is a mention of different types of control, and in particular vertical control. And the context of that explanation is in the context of doing urban control, where we have, say, benchmarks that are spaced, say, 20 or 30 kilometers apart. We have very high precision leveling between them so that the height difference between them is known very well, but they're spaced quite a ways apart. Now, because they're so far apart, they may not be used all that often. So if we think of marketing control to surveyors in an urban environment, we would want them to have benchmarks available to them with elevation values that are within a reasonable distance to make the connections. Otherwise, they'll just do some arbitrary elevation reference and go on, and nothing will fit with anything else later on. So we have benchmarks of a higher precision but greater spacing. We use those to control connections and the establishment of benchmarks that are closer together but not quite as precise. And similarly, we could use those and do things that are closer together again, but not quite as precise. And we also look at it from the point of view of the way things were adjusted. The higher order measurements were adjusted to get the elevations. Those elevations then served as control for the next lower order, and then again for the next order below that. So they didn't have these humongous matrices to invert. So quality of elevation difference is a higher quality but less spacing, and therefore probably not as convenient to use. So we have published by the Geodetic Survey of Canada vertical control, and I think if anyone is in an area that's reasonably well established and is close to probably an old railway line, you would come across these benchmarks. And in some municipalities I've noticed there's usually quite a few downtown, because originally the railway station was downtown and the rail line ran through the downtown. So you could find these vertical control benchmarks quite often. And this has placed the use of these then in the context of a typical city block, which is sometimes around 300 meters or so. And there's a construction project within it. And we want to be able to provide the vertical control for that area. So I'll just go to, now we have the Surveying and Mapping Branch 1978 publication with a very long title, The Specifications and Recommendations for Control Surveys and Survey Markers. The horizontal control section is now only for historical interest, but the vertical control portion and to some extent the related discussion on benchmark or survey marker construction is still pertinent. And we see Canadian special order benchmarks are diagonally opposite corners of the project. So if we take a 300 by 300 meter square, at two opposite corners would be these special order benchmarks. And they're only accessible by going directly out to the outside of the block and along the street. So that means if you're at one corner, it would be 300 meters to go to each one. If you were in the middle, you would have to go directly out and across. Now, if we take the process that is related to special order control, we know from the specifications how well the height difference is known. But the problem is that the way the specifications are phrased, it doesn't directly give us the quality of the height difference between the benchmarks. It gives what the limit is on the difference between a forward and backward leveling between two benchmarks. So we have to convert that into an uncertainty in the height difference between the two benchmarks, which requires a bit of algebraic manipulation, and realizing also the percentages and the lengths of sight. So, special order according to the Surveys and Mapping Branch publication, the allowable discrepancy between forward and backward levelings is 3 millimeters times the square root of K. And the value of K is the horizontal spacing between benchmarks in kilometers. If we remember that a height difference, let's call that delta H, is the average between a forward and backward height difference. So that means that the standard deviation of the height difference is 1 over root 2, the standard deviation of a forward measurement in one direction. The discrepancy, on the other hand, is the amount that's different between the forward and backward height differencing. So we have a bunch of root 2's floating around here. One of them is in the denominator, and then with the discrepancy, it's in the numerator. So the gist of all of this is that the standard deviation of a height difference between two special order benchmarks is 1/2 the discrepancy between the leveling according to that order. And it would be up to you, if you were to answer this question, to go through the algebra and illustrate how that comes about. Now the question is, would they be suitable to act as control? If we remember that we also are doing leveling that's an average of forward and backward whenever we do it, then it's just barely acceptable.